Loops in PCG are one of the most unnecessarily complex things out there, I think. It's not at all like the blueprint loops. And it's also not really like the C++ loops. It requires its own kind of methodology and nodes to do it. So I'm going to be showing you the basics and how to get started with them, as well as how to start implementing them with both data assets and with regular point systems. So to get started, I'm just using this PCG graph that I created last time. Is from my tutorial on showing how to use data assets. But again, this is just a loops tutorial, so you do not need this as the base to follow along. If you miss it and you want to start at the same place, check out the video right here. So this system here uses a data asset, and right now you see it is varied in height and in size, and they're all randomly rotated, but it doesn't use loops at the current moment. The way we did it in the past was to use an attribute noise and then take those values that we set up in the data asset, these right here, and then basically lerp between them using a variable noise for each point, which effectively gives us the randomization that we wanted. But it's not a great system and has some flaws, so this is where loops come in. Now, to begin with, I'm going to show you how to do it with just regular points, and then we're going to do it with the actual data asset system. So for regular points, I'm just going to detach all of this, not going to need it, and I'm just going to drag out of here and grab ourselves a static mesh spawner, and I'm just going to give ourselves some meshes, just some nice little trees. We can already add a transform points and do things of that nature, but there are some things you can do with loops that is unique, sort of like getting the index of the loop. So you can actually modify the points based now on the index of a loop, which means you can have them linearly start going higher and higher than the previous point, which you can't do easily with a basic setup. So to get started with a loop, you need to create a PCG graph that effectively will become the loop. So in the content browser, I'm going to right click and search PCG, and grab ourselves a PCG graph. And this is going to be our PCG increment up loop. And I'll go ahead and open it. And now here we are in our basic PCG graph system, where we can now start implementing that loop functionality. So for the input, if you just open it up, you can see it has an in, and for the output, it has an out, and they're both gray. Now for the input, we need to select it, and we can open these pins, open the index, and you can see all the information for it. You can change the usage, which is basically if it's a normal loop, if it loops on all of the things, or if it's a feedback loop. And a feedback loop is basically an even more advanced loop where if you put something in the output and the input as the same feedback of the same name and the same type, what it goes out into the output then returns into the input. So you can reshuffle it. There's a little bit of caveats to it, so we won't be going into it just today, but we'll be showing all the other things. And then the allowed types is the type of point it is. So you can see it is a spatial type. We can go ahead and change it to a point, and you can see the icon has changed. Now you can allow multiple data inputs or outputs and allow multiple connections. And if you uncheck these, you can see the point changes here. I'll go ahead and leave it by default. This is basically, do you want to be able to input multiple points into this? So in our case, we're going to be using a regular point system, so we'll keep it as that. And under pin status, you have advanced. By default, advanced basically just means it is hidden. So what is hidden? That just means the point, whatever is input or output, will not appear until you hit this button and open it. So if you wanted some things to just be hidden by default, you don't really need access to them normally, you can leave it on advanced. The other two options are just normal pins and required pins. Now we're going to make it required because we want to make sure that there is an input always. And we're actually going to be looping on these points. We're going to be looping on all the points that we have. So usage, instead of normal, we're going to set it to be loop. So you can see this endpoint has now this loop icon. And for the output, if we go ahead and select it, we can say allow types to be point and pin status normal. So that way we always see this output. So now we can go ahead and set up this loop in between these 2 points. And what I'm going to do is just grab ourselves a transform points, plug it in between one and the other. And now we can actually do whatever you want. If you wanted to, we could just set it up to be, rotate randomly within 360 degrees, and that's good enough. And now we have a loop. It'll just take all the points and rotate them. But that's not really the point of it, right? Because you could already do that by default. So something you can do now is if you right click, you can get loop index. So every time it goes through the point, it will then increment up. Let's actually offset the points upwards based on the actual loops and how many points there are. So to do that, we take our loop index, we go ahead and multiply it, right click and search create attribute. And for type, instead of double, we want vector. And I'm going to push it up, let's say 50 units. The output target can stay as none. That doesn't matter in this case. And we'll plug this into B. And from here, we're going to offset it, min and max, to be this offset. It's going to move it up, but let's also just scale it, because why not? So I'm going to take this attribute, I'm going to duplicate it over, and I'm going to plug it into scale, min, and max. And instead of this vector, I'll go ahead and change it to a float. I'll just set it to be 0.05. So it's going to start really small, and then it's going to get bigger and bigger and bigger and bigger. And that's all I'm doing here. So I can go ahead and close this, and this loop is pretty much done. So now to start using it, what you can do is take this loop, drag it into your PCG graph, and if you let go, you can see you can create it as a subgraph node or a loop node. So we want a loop node. And then plug this into our static mesh spawner, right? Well, as you can see, that doesn't actually work. And this is where I feel like, overcomplication of PCG comes in. So if I take our spline sampler and I press A, and I can go here in the bottom left corner, this is in 5.4, we can go ahead and select our actual graph in the level, and we can see it has all the points, you can see the index and all the information from them. So that's great. Why is it not working then? Well, the reason is all this point information is on this PCG point data. It is a single point of point data. Basically, the loops don't read all the points in the point data. They need as individual point data for each point, and then they can do it. So effectively, you have an array of points, but it doesn't want an array of points. It wants however many single inputs for each point. And there's a node for that. We can go ahead and detach the PCG loop. And right before this, we can go ahead and add ourselves an attribute partition node. And then we can plug this into the output. Now, by default, it comes in with an error, says at last is not found. So all you need to do is select it. In partition attribute selectors, go ahead and open that up. And instead of last, we'll go ahead and hit this plus button, and we'll change it to index. And now if we hit A, you can see we only have a single point here. And if I click on PCG point data, here's all our points split up. And you can see all 224 points are here. And it's actually effectively has split up an array and created individual versions into effectively another type of array. But the main thing from this is if I move this window out, you can see that we now have all of our trees getting bigger and moving up. Now they're moving up way too much. So let's change this 50 to, let's say, just 5. And you can much easier see that as they're going further in the sequence, it is actually going to increase this. And maybe the scale is too big and you can change the scale here. And now it's increasing less and it's moving up less. But you can see where this is how you effectively do a basic loop. And now you can pretty much do all the regular loop functionality and set it all up in this loop and it'll all work. If you're enjoying the tutorial so far, I would love to hit the like button and subscribe while you're at it to see more awesome tutorials like this. Now, loops with the data asset are a little bit more complicated because now you need to not only have the information on the points, you also need to have the information from the actual data asset and kind of weld them together and get the correct information for the correct thing. So I'll go ahead and just take all this. I'm going to comment it to be our regular point loop. And we'll detach this so we have access to it later on if needed. And now let's work with the data assets. So in my case, I already have a data asset and it's the same way as we needed before. We still need this match and set attributes. If I plug this in here and I grab the static mesh spawner, you can see that we now have our trees back based on the data asset that we have plugged in. So now how do we loop through these points? We can actually just go ahead and use this. And instead of the static mesh, right, we would use this static mesh spawner with the attribute. And it's doing the same thing, which is great. We can do this, but the problem is it's doing it to everything. No matter if it's a tree, if it's a little foliage piece, if it's a second type of, like, it doesn't matter what asset it is, it's doing it to everything. And you might want to do it to only some things because that's the whole point. That's why we have this information in a data asset so we can have unique things per asset and not have to have it all uniformly scaled no matter what asset it is. So let's create a new PCG loop, and this time for the data assets. Again, I'm going to right click, search PCG, and I'm going to type in PCG data asset loop. Just right away, I'm going to drag it out and create the loop node. And you can see nothing's actually plugged in. And again, because these are on advanced, that's why they're hidden. So I'll open it up and open these guys up and let's set up what we need. So for our input, I'm going to change this to be a regular normal node. I'll go ahead and just name the label points, and these are going to be of type point, and we're going to say this is required. For the output, also it's going to be points, allow type point, and pin status normal. For the output, if you choose required, it doesn't actually do anything. It effectively works as normal, so you might as well just select normal by default. But now we can do the same things here, but we need to actually get the information from our data assets. So for that, on our input, we want another pin input. We call the input just data. The usage will be a loop, and the type is going to be attribute set. Because if you see right here, we're outputting an attribute from this get property, and we need to go through each one and actually do something relative to it depending on the points. So before I plug this in, let me explain one other thing, which is this right here. So if I unplug the static mesh spawner, plug in this output into the points and this here, you can see I'm not using the attribute partition that we used here in between these guys because we want it all together as one big cluster that works for us. What we do want to do though is take this attribute partition and use it for this get property from object path. Search attribute partition, and just like before, for index instead of last, we want index, and this is going to go into our data. So if I sample this attribute partition with the A button, you can see here's our information that we have piped in. This is all of it here, and it has now been split up into the 3 different meshes. But now how do we actually tell which point it is here? So by using this match and set attributes, we have now added all of these attributes to the points. So if I press A and sample it, I can scroll to the right and we can see here's the static mesh, and it has assigned 1 to each section. So this is exactly what we want. Now we need to compare if one matches the other effectively. So in our loop, what we need to do is use an attribute filter. So grab yourself a regular attribute filter. The filter will be this data, and we need to see and compare 2 values. Now going in here, again, we have our static mesh, and in here, because we've added the same thing, we have our static mesh. So we know the static mesh is always going to be the same in both scenarios. We're just spawning it and then modifying it. So in our attribute filter, I can go ahead and type in static mesh. In my case, I've made it with a space, so make sure to add the space in. And I do the same thing for here. So right now, we're saying if static mesh is greater than static mesh, we don't want that. We want to make sure that it's equal, exactly equal. So we're comparing the two and making sure they're the same. So as long as the point information is the same mesh as the one I'm actually looping on, then this is fine. This will work. So from here, we can go ahead and get ourselves a transform points and plug this output into the points. So now we need to get the attributes from our data asset. Now, if you don't know, to get a specific attribute, instead of creating or get attribute, you need to use delete attribute. You search delete attributes, it comes up right here. And under operation, instead of delete selected attributes, you can keep only selected attributes. And effectively, this works as a get node. I'm not sure why it's done this way. I feel like this unnecessarily more confusing. So now we can keep a few attributes. So I'm going to keep rotation. I'm going to duplicate this, and I'm going to grab scale. Now, if we're sampling our actual data asset, you can see here's our scale. Here's our rotation. It is the same that we've created here for scale and rotation. So we can go ahead and utilize these values. So now if I open up transform points, it is just as simple as taking this rotation and plugging this into rotation max, and taking the scale and plugging this into scale max. So effectively, whatever value we put in, it is going to go between default, which is 1, 1, 1 in scale, and 0, 0, 0 for rotation, to whatever we have piped in. So now if we look here, you can see we have different sized trees. And if we pull up our data asset, if I wanted to change, for example, these little leaves, I can make them bigger. I can go ahead and change the scale to 10. And you can see it is actually scaling it all uniformly. But that is just a simple setup of our actual transform points. We have uniform scale turned on. If I just uncheck this, you can see it is now scaling in every direction. So again, we can go in here and just change this back to 2. And let's say change the verticality to 10. And now you can see it is nice and tall. And of course, you can do a scale min, scale max. You can add a Boolean and make it go between values. But you can see we're now able to control just this certain type of tree, just a certain type of object. So if I wanted to, I can make this one really tall so you can really see where it is. So the main thing that you need to remember is that attribute partition is pretty much your necessary extra node to do this. And if you split it up by index, it makes it quite simple to just go through every single point. Now, as always, the project files for this are going to be available on my Patreon, where you can join these wonderful people here in supporting what I do. And if you have any questions, you can leave them in the comments below, or join our Discord, the links for which are in the description below, as always. So thank you so much to the Patreons again. Let's get back to it. So these right here are the 2 basic type of loops that you can go ahead and start creating and looping on all your assets, and actually starting getting them far more advanced thanks to loops. Because remember, there's a lot of actual math available to you. If I just right click and search math, here's the attribute math operations. So you can do a lot of math here by default. So you can take your points and do a lot of these calculations right in here without a single custom node and just some simple loops. If you want to see more PCG tutorials like this, check out this video right here, where I show you how to use PCG to modify your landscape dynamically.